Your model just scored 85% accuracy. Quick, is that good? Here's the uncomfortable truth. You can't possibly know. Not yet. A score on its own means nothing. It only means something next to a reference. That reference is called a baseline. Look at this number floating on its own, 85%. Is it a triumph or an embarrassment? Without something to compare against, it's just a number. So before we celebrate any model, we build the simplest possible model first, and see what score that gets. Take our customer churn problem. Here are 100 customers. 85 of them stay, that's green, and 15 leave, in red. Now the dumbest possible model. Ignore every feature, and always guess the most common answer. Always predict stays. Count it up. It's right for all 85 who stayed, and wrong only for the 15 who left. That's 85% accuracy, from a model that never looked at the data. So now put your fancy model next to it. It also scored 85%. It tied the model that does nothing, all that training, and it learned nothing useful. That's the trap accuracy hides. To be worth anything, a model has to clearly beat its baseline. A model that reaches 92%, now that's real signal. Regression has a baseline too. If you're predicting a number, the simplest guess is to always predict the average. Here's the data, and here's that flat average line. The gaps from each point to the line are the baseline's errors. Any real regression model has to make those gaps smaller than just guessing the mean. Here's the mindset. A complex model has to earn its complexity. If it barely edges out the baseline, all that extra machinery isn't paying for itself. But if it clears the baseline by a wide margin, the model has found something real in the data. Always build the baseline first. It turns a meaningless score into a meaningful one. So, a score needs a reference. Predict the majority class for classification, or the mean for regression, and make your model beat it. But there's still a catch. To trust any of these scores, we have to measure them honestly, without peeking at the test set. That's what cross-validation is for. That's next.